Right, so in the first lecture, I want to start talking about state machines, but also a little bit about AI in general. So let's get at it right away. Now, yeah, AI stands for artificial intelligence, but I hope you already knew that because I don't know how you found this course if you didn't know that AI stands for artificial intelligence. And yeah, usually AI is compared between weak AI and strong AI. So weak AI is something that simulates a human brain, whereas strong AI thinks like a human brain. So weak AI is something that just emulates it and tries to be like it, but a strong AI is actually something that acts like a human brain. And yeah, like those robots in the fancy science fiction movies you all know. These are usually considered strong AI. Blade Runner is a good example for that. Well, mostly. Yeah, weak AI has very specific use cases. So yeah, and strong AI is a general purpose AI actually. Now, what do I mean with very specific use cases? For example, autocorrect, spell checker, autocomplete, IntelliSense, Siri, all of those stuff. Yeah. So whenever a computer is designed to work for a very specific task, that's weak AI. A strong AI, on the other hand, is something that would work in every situation, like the human brain. So if you put a human and put it in a dangerous situation, it will try to come up with solutions, and usually it's quite successful compared to, say, you put a stick there or something like that. Yeah. So it tries to figure out a solution. Now, if you put a weak AI, for example, if you use the autocorrect and put it into a dangerous situation in a robot, it will try to correct sentences as the fire approaches or as the acid gets higher every time. So that's the difference, you know? Strong AI is really general purpose, and that's also the definition of intelligence, or one of the many definitions of intelligence, that you are intelligent when you can react accordingly to a new situation that you've not necessarily been in before. All right. Now, let's take a little overview about the types of AI that there are. So these are by no means all the subtrees that you have from AI, but rather the most important ones. So we're going to look a little bit about the two big topics that we have here. That is machine learning and expert systems. Now, let's talk a little bit about expert systems. They're basically rather simple, so there are just many if-then statements, for example. Yeah, expert systems are very specific solutions for specific problems. So a state machine would be an example for an expert system. The behavior tree that we're going to look at is an expert system. Also, Google Maps is an expert system, and the AI in 99.99% of all games is just an expert system. Now, the problem of these expert systems is that if there are many if-then statements, things get really complicated. They're even gonna get exponentially complicated. With every new state, you have so many new things you need to consider that the progress becomes slow. Now, compared to that, we have machine learning. Machine learning is a very popular topic currently, and it usually works something like this. You have a program that's really stupid, but it can learn something. So you give the program, for example, 1,000,000 pictures of broccoli and 1,000,000 pictures of teddy bear, and you tell it the first 1,000,000 are broccoli, the second 1,000,000 are teddy bear, and it tries to figure out what are the similarities between all the broccolis and what are the differences to teddy bears and so on. And at some point it adjusts itself, and at some point it becomes rather good at detecting broccoli and determining if it's not a teddy bear, and so on. So yeah, this is basically how one specific kind of machine learning works. So the thing is, we've got two problems with that. Where do I get my data? And it takes a very long time to learn. So if you need to analyze 1 million pictures and then another 1 million pictures, that might take some time. But imagine you need to evaluate games of StarCraft or of Dota 2. So you need very skilled players who play. Then you need to save those replays. You need to save every action any player took at any given time, and where the enemies to him stand. And so it becomes really hard to do that. Okay, now things where you use these almost on a day-to-day basis are image recognition, because I've got a typo there. That's nice. Yeah. So for image recognition, for example, if you open on Android Google Photos, it usually does something as a back process. So it determines where are the dogs, where are the cats in the images. And if you tag something as dog and cat, you make the algorithm even more intelligent. But if you search for these things, you might find them. So that's where machine learning comes into play. And every time a dog is not detected, but it actually is a dog, and you tag it as a dog, the algorithm gets more intelligent. And if you know one of those "Are you a human?" captchas on, if you go to some website, there you usually need to click on, select all the pedestrian walks on the image, and then you need to select them. What we're doing there, I mean, you can already guess, we're training a neural network, which may be used by self-driving cars at some point. Yeah, that's machine learning. That's a very hot topic when you're not developing computer games. In computer games, it's a rather niche topic. There are experiments, but they're primarily experiments. What I find very interesting, there are a few experiments where they try to create a dynamic story from a machine that already learned how stories progress and what might be funny. So that way you could have, for example, a Dungeons and Dragons campaign without having a real dungeon master, but rather a computer that does this for you. So that might be very interesting, because that way there are no closed doors, because the computer comes up with an idea as soon as you do something that a normal game didn't want you to do. Good. That's very off topic. I got led away there quite a bit. Good. Let's talk about expert systems. Expert systems, the two things we're going to look at are state machines and behavior trees. These are rather simple AI implementations. Now let's look at state machines right away.